Okay, so now let's see what's inside this gamepad, and I will just take it apart and we will look at the board and how it's set up inside. Okay, so this may seem weird, a bit weird to you, why there are so many cables. If this is a USB gamepad, this was actually USB and PlayStation connector gamepad, so it had two connectors until I cut it because it had some issues with the connectivity and I had to remove the converter chip. Now it's only a USB gamepad. All I have to do is to find where are the USB connections on here. I would presume those four are the USB connections. Also, I can remove the analog sticks because I won't need them anymore. And we should check what's the resistance value on those. Let's see, on those potentiometers. They seem to be, if I'm not mistaken, they seem to be 10K because that's 1 0 and 3 zeros. But yeah, so on the joystick there are 100K, so we have to see how we can convert those values. 1.5, and on this side 3.7. It's kind of weird. It's completely pressed in one direction, but I guess these are should be 10Ks. So that's a problem for me because I have 100K potentiometers on the joystick. So it depends how this is driven, and so I can go ahead because the potentiometers on the joysticks are much higher, so that would mean less risk of breaking anything. So I will probably go ahead and connect it. We'll see how it works on the computer. The thing is, when I will get to the actually calibrating the joystick, two things can happen. So on the let's say calibration window, this would be 5K in the middle, so the resistance should go over the roof, and it could be somewhere over here, but there is a chance that the chip on the board is more adaptable and is able to tell, let's say, or it either measures the full resolution because it has 3 connections to the potentiometers on the analog sticks, so it either can measure a full resolution, so between because if you have in the middle, so let's say let's put a simple potentiometer here, right? 1, 2, 3 connection, and if you measure this and this, you have full resolution. If you measure this and let's say this and this, you will have the current state on this side. And if you measure this and this, so for example, you have a connection here and you measure those points, and then you have the rest of the resolution of the potentiometer. So if you have it set in the middle, if that's a 10K, then on this side it would be 5K, on this side 5K, and between them it would make it 10K. And it depends on the chip adaptability. So it is because it has all 3 connections, so it is informed about total resolution of the analog sticks and the current position. So if this is a very adaptable chip, then in that case it shouldn't have a problem with dealing with 10K potentiometer or so like so 100K over here. So it will basically measure the, let's say, distance between differential between this and make it and get a better idea about. However, I highly doubted that, and in this chip gamepad, that the chip is that adaptable, and it will probably have an issue and it won't be calibrating perfectly. Other thing is the resolution, because if you have any digital chip, you have to take into consideration that it's measuring resolution. So if it's made to measure 10K resistance, it's less able it won't have as precise measurements because of the 100K, because it would go over the scale. So I will have to think how to solve this. But well, we will deal with this when I will get there. And let's basically disconnect all of this, find the USB connections, replace this cable, remove those additional buttons because I won't be using them, and replace this board with connections to actual joystick. And we will see about it later, because we have our HUD here, our 4 buttons here, analog mode on off here, and this will be really useful for me. And the let's say joystick connections and the throttle. So this would be the joystick and this would be throttle. So I will check this out and see how it actually appears on the computer after the modification. Okay, as you can see, I removed all of the connections from the gamepad board and also removed the board from the joystick. So only thing remaining is here are cables. I also numbered the points on the connector to the analog sticks, and just let me show you how it's done. This is simple from 1 to 8, so 1 to 8, and basically there are 2 common connectors that are beginning and the end of the potentiometers. I may have swapped them out either way. There are 2 of them, and the relation is measured by this slider pin, so the middle pin. And so for example, you have to keep in mind this is most simplest representation, like the potentiometer that it's like so. So there is a, let's say, most simple potentiometer. There is a board. There is a connector. There is a slider onto the board. Just draw it like so. I mean the slider, the resistive path. So let's call this a resistive path, right? And there is a connection on this side. There is a, let's say, beginning end. Either way is fine, basically. So let's say this is this has a value of 10K, just like with the analog sticks. And from, if I would measure this point, so this point and this point, I have a ohm reading in ohms, and that would read me 10K always, because of the whole resistive path. There is also another connection that's connected to the slider. That's a conductor in the middle. Often it has something like a flat screw to move it around, and basically it forms, so it has a point where it touches the resistive path. And for example, it's like this, it's a circle, and there is another pad connected to it, so yeah, on the back of it. and let's say this is 2/3. So if I measure between here and here, and my ohm reading at the moment, because this will change when I change the slider position, this would be 1/3, so 3.3 K, right? And again, if I measure over here, this would mean that this is 6.6 or 6.7 K. And this is how this is done. So to limit the amount of connections, for my purpose, it's really perfect, because I have the slider over here, and I can basically and I have all the connections I need there. There are 2 connections to the to this part, and also to this to the slider part, so that's perfectly fine with me. And I can wire this to here, and we will see what will happen when I connect this to an USB board. I won't bore you with this, because I will simply wire. So let's see. Basically a slider for. Okay, so this would be my comments. So I will use additional wire links to make it work without a board, and this would be simply the X1. So this one, the middle of the slider will be connected here, the Y1, so this one, and this would be in the future my well, I think Y2, because yeah, back to front. Okay, so let's try this, and I will solder this and will show you the results. Okay, because I'm pretty lazy, I'm only connected the throttle instead of the joystick to the gamepad here. And what we see here, the important part is right here, the axis 5. Yeah, can you see that? I mean, I presume the rests are changing, because there are some changes on the internal, on the chip, because those are not connected. Yeah, you can see here that they are changing, but it doesn't matter for now. Just look at the axis 5. So this is 1, getting down. See that? 0. I mean, there is a lot of dead zone. It stops. I'm moving this smoothly, but it stops. Okay, so there is also a dead zone at the beginning and at the end. But what this tells me is that it works basically. The dead zones are for the analog sticks, because these chips probably will smooth out all the unwanted changes of the analog sticks, because all you want to have the middle of the analog sticks basically steady, and also at the end you want to have it to latch, let's say, to the beginning, right? So that's on here, and the end stand is state. So that's why this doesn't work exactly as expected. But to be honest, I'm pretty stoked about the results, because this is 100 kilo ohms and the original potentiometers were 10Ks. So that's really good. The reason why I didn't connect the joystick, let me show you that. Okay, let's disconnect this before I will break something. Let's see if you can see this. I have to hold this down, the contraption, but you should be able to. This moves, right? That seems fine. Okay, the reason why I didn't connect this is because on the slider there is something like that. Slider looks like this, and there are top and let's say bottom connection here. This is the output, and there are actually only two outputs. I'm not really sure yet what this third third one does, and there is a resistive, probably resistive path here, and probably non-resistive path here, and the slider, which is completely mechanical, simply slides around this and connects those two. So there is a resistive path here and completely conductive path here. So it only changes the resistance. So we don't have this this arrangement on the joystick. So yeah, as I draw it before, 1, 2, and 3 for the slider. We have something like half of this. Let's say 1 and 2, and this is the path. So we are missing this part. I will have to modify this somehow to get back the third one, and hopefully after that I will be able to connect everything to the analog sticks, and we will see if that will work. The dead zone will work for us actually for the joystick part, because we don't want to have any delicate wobble around the middle part, and also we want to have a latch on the end part, so there is no uncertainty that you are pushing it completely forward or pushing it completely backward, or left or right in that manner. I will try to modify it, and we will see how this will work for me. Okay, so the way I looked at it without disassembling it simply deceived me, so I guess I was mistaken. So this is actually this one with the 3 connections, because as you can see here, those two at the bottom are connected and they form a 100k resistor. This is the resistive path and this is the conductive path. So from here to here is 100k, here and here, and this is the slider that moves on the path. So instead of having something like this, let's number this 1, 2, and 3. 2 is a slider. This would be the 2. Let's say 1 and 3. All right. So, well, that's pretty simple right now. All I have to do is this would be on my other connection right here. This is, let's say, C1, C2, and this is my this would be an x-axis, so this one. So the first one is x-axis, the 4th pin. The second one is, let's say, C1. We will see about that. Basically the way I will connect this, it would change the direction of the connection. So this is the C1 and this is the C2. So this seems pretty good. I will connect this now and we will see how this looks on the computer. Let me just show you on this shitty meter that this is 1 and 3, 100. Doesn't matter where the slider is on, always 100 or so. And let's say from this one to the beginning, 100, so because it's at the end, and 0 because it's at the end. The other way around, this will be a 0 and this is 100. Perfect, it works really nice. Okay, let me solder all of this. We will see how the axis will work and what we can get out of it.